question is, if A is a real number, try to understand the question. You should know the properties of inequalities also. The real A is a real number, this A is a real number, and the number A is between 0 to 1. So 0 to 1 means obviously the numbers will be in point 1 by 2, 1 by 3, 1 by 4. This is the value of A. Okay. So A will belongs to from 0 to 1, means greater than 0 and less than 1. Okay. So now the function, let us take this in this interval of real numbers, 2 points, such that x1 is less than x2. So I'm saying that if x1 means power, x1 means this is the power ax1. So if 1 by 4 means 1 by 4 is less than 1 by 2, obviously left side is coming on the number line. So 1 by 4 will be less than 1 by 3. 1 by 4 will be less than 1 by 2. We are taking 1 by 2. If we put, or 1 is less than 3, you can say same thing. 1 is the power, we are taking the power as this. So 1 is less than 3. But if we will put 1 power on 1 by 4 and 1 by 2, any point on this, suppose at 1 the value of the function is 1 by 4 and value of the function at 3 is 1 by 2. So 1 by a to the power 1 by 4 to the power 1 and 1 by 2 to the power 3. So this power is less, but the value you will see that 1 by 4, if you find this will become 1 by 8. So which is greater? This is less than, so this 1 by 4 will be greater than 1 by 8, obviously. So therefore a raised to power x1 will be greater than a raised to power x2 because of this property. So this you should keep in mind. So that means this implies that f x1 is greater than f x2. Therefore fx is strictly increasing. Hence fx is strictly strictly decreasing on R. Strictly decreasing on R. You can take one more question that is easy than this one, that show that fx is equal to 3x plus 5 is a strictly increasing function. Is a strictly increasing function in which interval? On real numbers. Interval of real numbers. So as we have seen the previous example, we have given the function fx is equal to 3x plus 5. Now we will take 2 points, let two real numbers x1 and x2 belongs to R such that x1 is less than equal to x2. Okay, x1 is less than equal to x2. Then as x1 is less than equal to x2, okay, we can multiply both sides by 3. So this will become 3x1 is less than equal to 3x2 because we have to make 3x plus 5. And adding 5 on both the sides, properties of inequality, we can add both the sides 5, 3x2 plus 5. So this is what? This is fx1, which implies that this is the value of fx1. So fx1 is also less than fx2. So in case of increasing function, sometimes it is easier. So therefore fx1 is less than fx2. And thus we can say that x1 is less than x2 implies that fx1 is also less than fx2 for all x1, x2 belongs to the real number. Hence, fx is strictly increasing. Fx is strictly increasing on our real numbers. On real numbers. Strictly increasing on real numbers. So like this we can prove. Now we have, this is the first type of questions, but now we have another way of finding whether the function is decreasing or increasing. That is very easy, but you should know derivative. You have done the previous differentiability, continuity and differentiability chapter, you can easily understand. So that theorem is first derivative test for increasing and decreasing function. So generally we are preferring this one, and I will tell you the geometrical interpretation of this one also. The first derivative test, this is called first derivative. Derivative means differentiation. We will find the differentiation and we can say that whether the function is increasing or decreasing. So that is why it is called first derivative test for increasing and decreasing functions. Means by differentiating we can find out whether the function is decreasing or decreasing at that point in that interval. Okay, understood? So to check, we have the theorem. This is the theorem, or you can say this is the first derivative test. First thing, the f should be continuous. Let f be continuous. Continuous function, it should be a continuous function. Continuous function be continuous on the closed interval AB. And it is also differentiable. It is also differentiable in the open interval. Differentiable is always on the open interval. On the open interval, open interval means A and B are included. The closed interval A and B are included. Open interval A and B are not included. Then number one, f is increasing in this interval. F is increasing in this interval, in the closed interval AB. This closed interval AB, it is increasing if we find the derivative at that point. F dash x dash means derivative d by dx of fx. If the derivative is greater than 0 for all x belongs to the open interval AB. Okay, x is increasing. Why? If you have seen the differentiability and in geometrical interpretation of differentiability, we have seen that what is increasing function? Increasing function is like this. So on increasing function at any point, if you will make a tangent, this will make a positive angle. This will be the theta. This theta is positive angle. Okay. And tan theta will be positive. Tan theta means this tan theta will be positive because it will be a acute angle. So tan theta is positive. What is tan theta? Tan theta is nothing but it is the derivative. Dy by dx is the slope of that tangent at that point is called the slope. Suppose this is the point P at which we are considering this tangent. So this tangent will have the slope, positive slope, and this is the negative slope. This is positive slope. Okay. So like this, we can see that whether the slope is positive or negative. So when it is positive slope, that means the curve will be like this. When curve will be like this, it will be increasing. And when the curve is decreasing, if it is decreasing at this point, if I want to draw one tangent at this point, suppose this point, then it is decreasing. This point is Q. At this point, if the tangent is like this, that means it is having obtuse angle. So that means tan theta is negative. Tan theta is negative. Tan theta means derivative. So at this point, derivative. Derivative means f dash x. Same thing. F dash x or derivative both are same. So dy by dx will be negative. That means less than 0. If it is greater than 0, we can say the function is increasing. And second point, if f is decreasing, then means we have to check the derivative. If it is positive, the function is increasing. If we find the derivative and it is negative, derivative is negative, then it is a decreasing. It is a decreasing function. F is decreasing. Maybe if f dash x is less than 0 for all x belongs to the closed interval, open interval AB, sorry. Okay. And if f is constant, third thing also can happen, that if f is a constant function, any constant function is like this straight line. This is a, if it is a straight line, fx is constant. This function is called constant function. If it is a straight line. So f is a constant function. If f is a constant function, you know that if it is a constant function, we cannot draw the tangent. Tangent will be a straight line and the derivative will be 0 because this will not make any angle with the x-axis. So that's why f dash x for constant function is 0 for all x belongs to AB. The constant function is not decreasing or increasing. It is a constant function. It cannot be increasing or decreasing. So we have to find out by finding the differentiation. Okay, previous chapter, you know that one. For example, show that the function show that the function fx is equal to x cube x cube minus 6x square plus 12x minus 18 is an increasing function, increasing function on real number R. So sometimes we have given the point, then we can find the derivative at that point. Find the derivative, it is positive, increasing, negative, decreasing. But here we have to use some properties. So first we have to find f dash x. F dash x means differential of this function d by dx of this whole function d by dx of x cube. F dash means what? If fx is, we are taking y in differentiation, so we are writing dy by dx, correct? So dy by dx or f dash x is same thing. So minus 6 will come out, d by dx of x square, and plus 12 will be out. So we will find the differential of x, and differential of the constant number is 0. So this is 0. And this is the formula that will be used here. I'm writing for your convenience. X raised to the power n, differential of x raised to power n will be nx n minus 1. This formula is used here, here, and here. So we have 3x square, 6 into 2x, differential of this nx n minus 1, and differential of x is 1. So this will become 3x square minus 6 2s are 12x plus 12. Now how we can check that whether it is positive or negative? So we have two things. If we can make the whole square, the square is always positive. So here if you will take 3 common, you have with x square minus 4x plus 4, and this minus x square minus 4x plus 4 is the whole square of x minus 2. X minus 2 whole square, if you will find, you will get what? X square minus 2 to the 4x plus square of 2 is 4. So this is the same. So we can write 3 into x minus 2 whole square. The square is always greater than equal to 0. Okay. And 3 is already positive. That means this is greater than equal to 0 for all x belongs to R. So it is increasing. Greater than equal to, therefore it is increasing. If it is greater than, we can say strictly increasing. So thus we got that derivative is positive. Thus we can say that f dash x is greater than equal to 0 for all x belongs to real numbers. Hence fx is an increasing function in the interval, then increasing function on real number R, on real number. Okay. So like this, we have to find out the derivative. Sometimes we have given the point, we can check easily. Sometimes we have to use the properties. And sometimes trigonometry will be involved. For example, you can have another example in which you have to show the trigonometrical function. So show that the function fx is equal to cos square x is strictly, now you can see that function cos and sine function is like this. So they are somewhere in some interval they are increasing, in some interval they are decreasing. So always in trigonometrical function you will find some interval, so it is decreasing, strictly decreasing. We have to show that it is strictly decreasing on the interval 0 to 90 degree pi by 2. 0 to 90 degree it will be decreasing function. Okay. So we have fx is equal to cos square x. We have to check the derivative, differentiate. On differentiating both sides, differentiate both sides with respect to x. So differentiate both sides with respect to x. So left side differential is f dash x. We can directly write d by dx of fx is f dash x. You write d by dx of fx means differential of fx. This can be represented as f dash. F dash means first derivative dy by dx. And right side we have to differentiate. So differential of, as I told you, x square. So differential of square is 2 nx n minus 1, 2 into cos x, chain rule, into differential of cos x is minus sin x. Okay, this we have done. So minus, you are getting minus 2 sin x cos x, and the formula for sin x, 2 sin x cos x is equal to sin 2x. So minus 2 sin 2x. Okay. Up now we have to check that sin 2 sin 2x. This is 2 sin 2x. So negative 2 sin 2x, and sin 2x from 0 to 90 degree is sin 2x is positive from 0 to 90 degree. Sin 2x is greater than equal to 0 means positive in the interval 0 to 90 degree. Always you will find the positive value sin 0 degree zeros. Okay. Sin 30 degree, sin 45 degree, 1 by 2, 1 by root 2, root 3 by 2, 91. So all positive. So it is greater than 0. Is positive. So positive into negative will be negative. That means this total value will be this minus 2 sin 2x will be less than 0, because the overall result will be negative. So x1 is less than, means negative, less than 0 means it is strictly decreasing function. Prove. Therefore, fx is strictly decreasing function on the interval. Fx is strictly decreasing function on the interval 0 to pi by 2. Okay, got it? So like this we can have more questions, so that some, now we have the another type of questions. There we have to find the intervals, in which interval it is increasing or in which interval it is decreasing. So there is a working rule to find in which interval it is increasing or in which interval it is decreasing. We have to show that the given function fx is equal to sin x is strictly increasing in 0 to pi by 2 first. So a part is strictly increasing. So we have the function fx is equal to sin x. Okay. Now we have to find the differential of this f dash x. F dash x differential of sin x is cos x. Differential of sin x is cos x for all here which interval x belongs to the interval 0 to pi by 2, 0 to 90 degree. So as I told you, 0 to 90 degree means first quadrant. You can understand by this way also, in which quadrant 0 to 90 degree, 0 to 90 degree is first quadrant. So 0 to 90 degree pi by 2 and 90 degree. This is first quadrant. Here all positive. All values are positive. All, then here sine is positive. Here tan is positive. Here cos is positive. Sine is positive, tan is positive, cos is positive. So therefore 0 to 90 degree all is positive. That means cos x is greater than 0. Positive means greater than 0. Therefore prove that fx is strictly increasing in this, strictly decreasing. The interval 0 to pi by 2. Now strictly decreasing pi by 2 to pi. Pi by 2 to pi means second quadrant. This is second quadrant. In second quadrant, B part, in second quadrant, f dash x is equal to cos x. And second quadrant sign is positive. Cos is negative. Therefore, cos will be negative, means less than 0. When it is less than 0? When less than 0, because for all x belongs to, for all it depends in the value on, in the value of x. X belongs to pi by 2 to pi is decreasing. So therefore, f dash x is less, f dash x is less than 0, means it is strictly decreasing. So fx is strictly decreasing in the interval pi by 2 to pi. So if you see the diagram, we have seen the 0, 0 to pi by 2, pi by 2 to pi. 0 to pi by 2, it is increasing. Cos x is increasing in 0 to pi by 2, means increasing means like this, and pi by 2 to pi it is decreasing. Okay. So as we have seen in this whole interval, it is increasing. If we see from 0 to pi by 0 to pi, so half interval it is increasing, in half interval it is decreasing. Try to understand this interval, it is totally increasing. In this interval, it is totally decreasing. If we see from 0 to pi, so in this interval, it is increasing from 0 to pi by 2 and decreasing from pi by 2 to pi. Okay. So f dash x is great positive. So that's why it is called neither increasing nor decreasing. So how we will write? We can see that we can say that when x belongs to the interval 0 to pi, then we have seen that, or we know that f dash x, as we have seen here, f dash x positive is positive in the interval 0 to pi by 2, 0 to pi by 2, and f dash x is negative